Today we're looking at special angles and the unit circle. So we've already talked about special angles in those triangles, the 30, 60, 90 triangle and the 45, 45, 90 triangle. And so now we're going to look at angles that are perhaps bigger than 90 degrees. So remember, we graph them on an XY axis, and then we'll talk about basically a unit circle means the radius of that circle is 1. So let's get started here. So it says a circle is defined by a set of points that are equidistant from a fixed point called the center. So let me just get my pen ready here. Okay. The distance between any point on the circle and the center is called the radius. Okay, so that's nothing new. A circle of radius r and center 0, 0 is shown below. The point xy lies on the circle, right? So it could be there, it could be here, whatever. It's just a general point. It says draw a right triangle in a convenient position and use the Pythagorean theorem to find the relationship between x, y, and r. So really there is only one position. If you're using x and y, well, I guess you could do it with the y-axis, but we are not going to do it with the y-axis. We are going to want to, let me change the color here, form it with the with the x-axis, so like this. Okay, so kind of like how we formed our reference angles in that lesson. Okay, we wanted this angle here, so we're going to form a right triangle with the x-axis, not with the y. So saying that, when we look at our coordinates here, right, that's your x value, and this is your y value, so your y is here. Okay, this is the y-axis, right? That's just in general. This is your general point. So often I'll just show it there, right? So this x could be negative, or if it was over in this quadrant, it would be positive in the first or fourth. In the second or third, x could be negative, or it has to be. So it represents a location. The absolute value of it, right, if you made that positive, it would be the distance. Okay, so now find the relationship between x, y, and r. Okay, well, r squared is the hypotenuse, r is the hypotenuse, so r squared equals x squared plus y squared. Okay, that's the Pythagorean theorem. So that is the relationship. That actually gets you every point on that circle. So that's the equation of a circle. So you actually, even though we're doing trig, you just found out a new equation for a relation. It's not a function because it's a circle if you do the vertical line test, but that's the equation of any circle that has a center of 0, 0. Okay, so center 0, 0. Okay, so I'm just going to rewrite it out here. R squared equals x squared plus y squared. Remember when we talked about functions, we knew that if y was squared, it wasn't a function. So that confirms it as well. So now it says write the equation of a circle centered at the origin with radius of 5. So now we put 5 in for r. Okay, and square it. Now, I've been putting r first. I'm going to rearrange that. Actually, I'm going to go back here and just copy it twice if you haven't got to that. So I'm going to put x squared plus y squared equals 25. Kind of like anything, we like to have the variables first and then the number. Okay, radius 1 would be x squared plus y squared equals 1 squared, which is just 1. Okay, so that's what's called the unit circle. So a circle centered at the origin with a radius 1 is called the unit circle. Okay, so this kind of means 1 unit. All right, so that's going to help us a little bit. All right, so looking at our special angles. So before, when we were doing a 45, 45, 90, we had a side of 1, 1, I'll just make that a little bigger, 1, 1, and root 2. Let's put it here. Okay, when we were learning about special angles. And then I showed you, okay, well, what about if we wanted our radius to, our hypotenuse to have a value of 1? Well, we would have to divide that by root 2, right? And if we divide that by root 2, we have to divide every side by root 2. Okay, so really, I'm just going to move that, make this a little bit bigger here. So this was 1, now we're dividing by root 2, was 1, now we're dividing by root 2. Okay, so now we can know what our sine and cosine are of 45, 1 over root 2. If we rationalize, then remember this is equal to root 2 over 2. So we did that in the last lesson. All right, so if you can remember the sides as root 2 over 2, both the legs of the triangle, and the hypotenuse is 1, then that's going to help us when we try to graph this on the unit circle, because we want the radius of the circle to be 1, and that's going to be the hypotenuse. If you take a look at the 30, 60, 90, then again, we had, before we had the hypotenuse of 2, this leg is 1, and this was root 3. Okay, and so now if we want this to be 1, we'd have to divide by 2. Okay, and that means you have to divide every side by 2 to make it proportional, right? Similar triangles. So now our sides are 1/2, the shortest side, root 3 over 2, the middle side, and the hypotenuse is 1. Similarly over here, this is the same triangle, just flipped on its side basically. And so again, this was 2, this was 1, this was root 3, and now we divide each side by 2, okay, to keep them proportional. So that's what we're going to use to help us in a minute here. Okay, so a unit circle is shown below with some points on the terminal arm of angles that are multiples of the special angles. Label the measures of these angles and use your answers from question 4 and symmetry to state the coordinates of each indicated point. So if I put here, if I form the 30-degree angle, okay, it's already labeled. So by 30 degrees, it doesn't mean it's here. It's just that this terminal arm forms a 30-degree down here at the origin. Okay, here's your initial arm. All right. So really, when we draw, if we were to draw a triangle, we would draw it from going down here to form 90 degrees, right? So this would be your 30 degrees. So remember, if this is the unit circle, this radius is going to be 1 unit. So this is a 30 degree here, this would be a 60 up here, and a 90. So the 30 degree is at the origin. That means it's opposite the smaller side. So that means y here is 1/2. Okay, so maybe I'll do a split screen here. Okay, so if you take a look at the 30 here, opposite the 30 was 1/2. So that's going to be your y value. Okay, your x value is adjacent to it, and it's root 3 over 2. All right, so now we know the coordinates on the unit circle with the point that makes a 30-degree angle in standard position. So now if we want to do the same for the 45, maybe I'll do it in green. So here, all right, and so then when I draw my triangle here, okay, so that's going to be 45 here, which means it's 45 at the top. So that's the first triangle. So your x value is root 2 over 2 and your y value is root 2 over 2. All right, they've got to be the same. Take a look at how it cuts the circle. So here's the first quadrant. 45 degrees cuts it in half. Okay, so it's going to be on the line y equals x. So those coordinates have to be the same. Then let's do, I'll do it in blue. Let's blue here. So here we go up to the 60 and then draw a triangle from there. So this whole angle here is 60. All right, so that would be this one. So opposite is root 3 over, oh, did I put a 2 there? That should be a 2. Root 3 over 2. And the next one should be, and the x should be 1/2. Okay, so this is, x is 1/2, root 3 over 2. All right, and then, so those are your special angles, 30, 45, and 60. Take a look. 0 and 90 are considered special angles as well. We don't even have to think about it though. It doesn't form a triangle. At this point here, if it's a unit circle, the x value is 1 and the y value is 0. Here, if the radius is 1, then the x value is 0 and the y value is 1. Then to get these other dots, if you take a look at it, if I draw a line from the origin to this point here, and you compare it to the blue on the right side, it's exactly the same. It just is reflected over the y-axis. So think about what's going to happen when we look for our x and y coordinates. If I drop this down here, okay, then this distance is going to be the same as this one, except in the negative direction. So this is going to be negative 1/2, and the y value will be the same because it's directly opposite. So that's going to be root 3 over 2. Okay, then the same thing's going to go for the next one. If I graph this terminal arm, oops, I'm going to do that again. I ran out of tablet. So if I do this again, sorry, just try to get the same color. If I do that and you compare to the green on the right, it's the exact same except reflected. Okay, so then we draw our triangle down if you need to. Okay, and then compare that distance there is going to be the same as this distance here, which is root 2 over 2, but it's in the negative direction. So negative root 2 over 2 for x, and the y value stays the same. And then the last one, the red one. So from here to here is the same except reflected. So we draw a triangle down here. That distance is the same as that, except in the negative direction. So negative root 3 over 2 and positive 1/2. Okay. And then over here we have, again, on the horizontal axis, you'd have an x value of -1, a y value of 0. So down here, you would have a x value of 0, a y value of -1. Okay, and then all of these are going to be reflections as well. So this first one here, I'm just going to freehand it. Okay, if we look at that, it's going to have the same x value as the one above, and then it's going to have the reflected y value, so -1/2. Okay, then if we did the green one, I'm just going to freehand it to here, all right, and then draw that. The triangle is going to have the same x value, so that's going to be -√2/2, and now the y value will be reflected, so -√2/2 as well. All right, and then the blue, freehanded to here, is the same as the triangle above, or same as this one, rotated all the way around. So same x value, -1/2, and now negative y value. Okay, and then same, I'm going to freehand this one. Draw the triangle so you can compare it to the previous or the one in the first quadrant. Same x value and the y value has been reflected. Okay, then the green. Okay, and then oops, do that and draw. Okay, that's going to be the same, so √2/2, and then y is negative, and then the red. So really, we've now introduced a whole bunch more special angles, but they all have reference angles of 30, 60, or 30, 60, or 45. So this is going to be √3/2 and -1/2. Okay, so they all have the same reference angle. So all of these coordinates have the same digits, okay, but they're either positive or negative. And then we've also introduced the special angles of 0, 90, 180, 270, which again are all multiples of 90. So I'm going to go to the next part here. So recall that for any point xy on the terminal arm of theta, an angle in standard position has cos of theta equaling x/r and sine of theta equaling y/r, where r is the distance from the point to 0, 0. For all the points above, the above points on the unit circle, r is 1, because it's a unit circle. Therefore, for each point on the unit circle, cos of theta is x/1, sine is y/1. So basically, when you divide by 1, it really means x is cos theta and y is sine theta. So anytime you look at a point on the unit circle, you know the sine and cosine ratio, right? The first element is the cosine, second is the sine. So if theta is an angle in standard position and xy is a point on the unit circle that is also on the terminal arm of theta, then there are your coordinates. That makes life pretty easy. So now for tan is y/x. Okay, so here tan of y/x is then going to be, so this is going to be equal to sine theta over cosine theta. So anytime you see the points on the unit circle, you can find tangent of them by just taking the ratio y/x, because that's sine theta over cos theta. Okay, so just another definition of it. But in any case, it says determine the tangent of each of the above angles. So, well, tan of theta, okay, should put the angle in. So we have already done all the basic ones. So tan of 30, so that's opposite over adjacent, or y/x. they all have the same denominator. So that's going to be 1 over root 3. We've already done this before, which is root 3 over 3. Tan of 45 is exact same values, y and x, so that's going to be 1. Tan of 60, root 3 over 2 over half, the 2's divide out, so that's root 3. Okay, then if we did tan of this next angle, this blue one, so that was 60 degrees, so this would be 120. Oh yeah, we need to go through and state those angles too. So actually, let's go do that right now. So these were 30, 45, 60, then that's 90. So then this blue one here, I'm just going to label it at the top of it. So this would be for 120 degrees, right? Because that's 60 and then another 60. Then, or you can go 180 minus 60, the reference angle. So this green one, 180 minus the reference of 45 is 135. Then 180 minus the reference of 30 is 150. Okay, obviously this is 180. Then 180 plus 30 is 210. Then 180 plus 45 is 225. 180 plus 60 is 240. This is 270. Then here you could go 360 minus 60 is 300. Then 360 minus 45 is 315. And 360 minus 30 is 330. Okay, so tan of 120, that's going to be basically the same as tan of 60 except opposite sign. So that's going to be negative root 3. Then tan of 135 is going to be the same as tan of 45 except negative. Then tan of 150 is going to be the same as tan of 30 except negative. And then in the next quadrant we have tan of 210. So that's going to be, when you look at tan of root 10, they're both negative. So that's going to be the same as 30, except it's going to be actually exactly the same as 30 because they're both negative. And then tan of 225 is going to be positive, same as tan of 45. And tan of 240 is going to be the same as well. So in quadrant 1 and quadrant 3, this was quadrant 3 angles, quadrant 2 angles, and this was quadrant 1 angles. So remember, we talked about it, where all the trig ratios are positive. So all students, so if I go back over here, all students take calculus. So all are positive in the first, so tan will be positive, and tan is positive in the third. Okay, and then you can find the fourth as well. I'll leave that for you to do. Okay, so now we're going to use the unit circle to state the exact value of each of the following trig ratios. So I actually can't get that on the screen at the same time, but actually I could move it. So give me a sec here. Okay, so I moved it so we can see it at the same time. So sine of 120. So you want to take a look at that. Remember, sine is going to be root 3 over 2, the y value. All right, so you may not always have the unit circle with you. So you want to think about how are you going to remember these? Well, you want to remember the reference angle. So you just go 180 minus 120 is 60. So that big angle is at the reference angle. So that means your sine is your middle side, basically, right? The radius is always the longest. So the middle side is going to have the root 3. All right, root 3 is bigger than 1. So you got to remember that. So sine of 315, that's going to be in the fourth quadrant. Anytime there's a 5 in it, it's going to be something to do with 45 degrees, right? So when you think about that, you're doing sine, it's going to be negative because it's in the fourth quadrant. And anything to do with 45 is going to be root 2 over 2. Now I know there are, there's some tricks to remembering these using, there's something like if you Google it, something on your hand about what is 1, 2, and root 3. So I don't remember it that way, but go for it. Like search it up if you need a way of remembering. Okay, sine of negative 90 is, think of negative goes down this way. So you're at the same as, that's equivalent to 270 degrees. So sine is the y value. So it's negative 1. 210 is in the second quadrant. So this is, 210 is right there. Okay. And so that has a y value of, we're doing sine for these, a y value of negative 1/2. So that's the sine. Okay, and then tan is negative, sine is of negative 225 is the green there. And again, it's negative root 2 over 2 because it's dealing with a 45-degree reference angle. Okay, so those were all sine. Now we'll do some cosines here. Cosine of 60. Okay, so that's the x value. So that's on the shortest side of that 30, 60, 90 triangle. So that's 1/2. 210 is again over here. So 210 is going to have a x value of negative root 3 over 2. So in the third quadrant, the x value is negative. So just remember that. Negative 30 is in the fourth quadrant, so it's going to be positive, and it's going to have cosine value of root 3 over 2. So anytime there's a reference angle of 30, cosine will be root 3 over 2 because it's that middle side. It's not the smallest side. Cos of 135 is the green there. And again, cos and sine of anything that has a reference angle of 45 is root 2 over 2, but this is in the second quadrant, so it'll be negative for cos. Cos of 180, that's a straight angle all the way here. Your x value is negative 1. Okay, now some tans. So tan, we already did some of these. So tan of 135, well, anything to do with a reference of 45 is going to be 1. It's in the second quadrant, so it's going to be negative 1. Tan of 300, so take a look at it here. So tan is y over x, so that's going to be negative root 3. Because negative root 3 over 2 over 1/2, the 2's divide out. Tan of 90, so that's y over x, which is 1 over 0. We don't like that. That does not exist. So we say it's undefined because you can't divide by 0. Okay, tan of 120 is here, so it's root 3 over 2 divided by negative 1/2, so it's going to be negative root 3. So anything to do with a reference angle of 60, like 300 and 120, is going to be root 3, either positive or negative. Okay, tan of negative 360. So really, that's the same as 0 degrees. So y over x, well, 0 divided by 1 is 0. Okay, so then a variety here, tan of 585. So take 585 and subtract 360. So what's that? 225. So that's the second quadrant. It's got a reference angle of 45, so you know it's going to be a 1. But it's in the, sorry, it's not second quadrant, it's third quadrant. They're both the same sign, so it is positive 1. Negative 315, well, if you add if you want to, you can add 360 to that. So that's going to be positive 45. And cosine, again, for 45 is going to be root 2 over 2. It's in the first quadrant, so it's positive. Negative 510 plus 360. What's that going to be? So 510 minus 360 is 150. Negative. Okay, so negative 150. Again, you could add 360 again, but there is your 90. Okay. Okay, so you're going to negative 150. It's going to be, there's 90 and 60 more, so it's going to be here, and we're looking for sine. So it's the y value is going to be negative 1/2. Tan of negative 120, so there's negative 90 and 30 more. Okay, so tan is going to be root 3, because again, the reference angle is 60. We talked about that. There were some already in the line above. So it's going to be root 3, positive because both the x and y coordinates are negative. And then negative 270 is the same as positive 90. For cosine, the x value there is 0. Okay, so this is going to take a little bit of time for you to get these, right? I've been doing it for a while. Use your reference circle here so that you can look back on it. But hopefully after a while, try to challenge yourself and then just draw the first quarter of the of the circle with the triangles. Then you're really just thinking about reflecting those for each one that you're required. You're not going to be asked every single trig ratio of every single angle. Okay, and it's really all about reflection so that you know what's positive and negative, because they're all the same values. You have to know 1/2, root 3 over 2, root 2 over 2, and zeros and ones. And then different opposite signs of that. Okay. All right, so it says solve each equation for theta. So now we're working backwards. So I've just moved the unit circle so you can access it on the screen here, but it's on your paper. So you want to look where you get a cosine ratio of root 3 over 2. So that's an x value of root 3 over 2. So that's the very first one here. So we know that theta is equal to 30 degrees. Okay, we have to list all the values between 0 and 360. So there's more than that. Where else do you see a root 3 over 2 for x? Well, you see it over here, but it's negative, so that doesn't count. Here, it's negative, that doesn't count. But over here in the fourth quadrant, so that has a reference angle of 30. 360 minus 30 is 330. So this is where knowing where your all trig ratios, sine is positive, tan is positive, cosine is positive, is helpful for you. So for the next one, where is cos negative? So cos is negative in the the second quadrant and the third quadrant. Okay, and so for 1/2, remember that's the shortest side, so that's going to be a reference angle of 60. So you might want to put this here. Reference equals 60. But if you take a look at in the second quadrant, because we said we would find it there, we get an x value of negative 1/2, and that's at 120. So 120 has a reference angle of 60. Then in the third quadrant, what has a reference angle of 60? 240. Okay, so the next one, where is sine negative? That's in the third quadrant and the fourth quadrant. So third and fourth. So we know to look there. And then the y value has to be root 3 over 2, right? So sine is your y value. So the longest side, it's going to be these ones that go down further, right, to give a longer angle. If you take a look there, there's negative root 3 over 2. So the reference angle here has to be 60 degrees as well. So theta is going to be 240, and then 360 minus 60 is 300. Okay. Next one, sine is positive, so that's the first and second quadrant. And notice how this is given as 1 over root 2. That's the same as root 2 over 2, if you rationalize it. Okay, let me just fix that. It's a mess. Okay, so we're looking in quadrants 1 and 2. When do we get this? We get it with a reference angle of 45 degrees. Okay, so what angles with a reference angle of 45 are located in the first and second quadrant? Well, in the first quadrant, it is 45. In the second quadrant, it would be 180 minus 45, which was 135. And then check them over here. So I'm trying to get away from using my circle all the time because you don't want to have to draw this out. So there's your 45, the green one there, and the green one there. Okay. Next, tan is -1. So tan is negative in the second quadrant and the fourth quadrant. The reference angle that gives you a 1 is going to be 45. So now if we're looking in the second quadrant with a reference of 45, that's going to be 135. In the fourth quadrant with a reference of 45, that's going to be 350. And now go and check. So your green there, if you divided the y with the x, you get -1. Here, divided by with the x, you get -1. Then tan of root 3. So tan is positive in the first and the third quadrants. Okay, reference angle for root 3. So that means your root 3 over 2 is bigger than your 1/2, right? So that means your y has to be your root 3, your bigger side. Okay, so that's going to be a reference angle of 60. So now, reference angle of 60 in the first quadrant is 60. In the third quadrant, that would be 180 plus 60 is 240. And then just check. So 60 here, if we go root 3 over 2 divided by 1/2, we get root 3. Blue one here, negative divided by negative is a positive. Same result. Okay, so I've just moved the circle again with all the right special angles there. Sorry. Okay, so express each of the following in terms of the trig ratio of the reference angle and evaluate. Express answers as an exact value. Okay, so in terms of the trig ratio of the reference angle, so cosine 120, so 120 is up here. How can we show that as the cosine of its reference angle, which is 60 degrees? Is it the same? Well, cosine in the second quadrant, that's going to be negative. So all that we're doing is basically taking these trig ratios, making the angle, the new angle in it, the reference angle. So it's all going to be less than 90. And then the only difference between any of these and the reference angle is either it stays the same or it is the opposite sign. So putting a negative in front. So sine of 240, we'll show that as sine of the reference angle of 240 is 60 degrees. Okay, 240's in the third quadrant and sine is negative. Okay, so that's going to be the same value. Tan of 135, so the reference angle is 45. So do we have to make that negative? Well, tan of 135, that's in the second quadrant. Tan of 45 is positive. Tan of 135 would be negative, so we have to change the sign of it to make it the same. So now these are equal to each other. Next one, reference angle of 225 is 45. That's in the third quadrant, so cos is negative there. Okay, reference angle of 330 is going to be 30 degrees. So it's really important to know how to get your reference angles. So 3 is 30 degrees. Sine is positive for 30 degrees, but negative in the fourth quadrant. So that's going to be negative there. And then reference angle for 210 is 30 degrees. And that's in the second quadrant, which is positive, so we don't have to change a thing. Okay, so if you were to enter cos of 120 in your calculator, negative cos of 60, you would have the same digits and the same sign. They'd both be negative. So all of those. All right, and that's it. We are done.